There are millions of bacteria on our planet, each one given a specific name to help identify it. Now, how do scientists differentiate one bacteria from a list of a million? The answer is simple. Using a dichotomous key and subjecting that bacterium to a series of tests. Alright, maybe that's not so simple. What is a dichotomous key? Don't worry, I have that answer for you guys. But first, let me lay out kind of what I'm going to go over in my speech. First, I'm going to cover what is a dichotomous key and what do we use it for. Second, I'm going to explain why I chose the test that I chose. And third, from the test results, I'm going to interpret them into identifying our unknown, sort of unifying the three together to obtain the solution. So, I'm going to give you guys a little bit of disclaimer here. You don't know what the bacteria is, it's unknown to you, but it's also unknown to me. So, essentially we're doing a blind test here. Now, if we use a dichotomous key though, it kind of acts like glasses for us. Helps us see maybe what's going on, what the bacteria is trying to tell us. The bacteria wants us to know who it is. So we're gonna listen. So, dichotomous key is almost like a flow chart, where if we look at our bacteria, wall behind me, we have 4 of them here, each with characteristics based on the tests. So, if we look at these characteristics, we're kind of able to form and pick what test we want to choose. So, we want to look for outliers in these characteristics. And these outliers are going to be what kind of like sets up our dichotomous key flow chart thing. So, dichotomous key, you start with your unknown at the top. And from your unknown, you make a fork where your first test is conducted. And from that first test, you get a split. On one side it could be this, on the other it could be that. Now, based on the results of the test, it's only going to go down one way. So you discard the other that, essentially. And from that, you keep doing that over and over, continuously looking at the characteristics of your bacteria of interest. So, the first test that I chose was a shape test, because we have an outlier right away in the shape test. Only one is coccus shaped, or a circle. The other 3 are rod shaped. So, looking under a microscope at our bacteria, I found that our bacterium, unfortunately, was a bacillus shape. So, check that off the list. Goodbye coccus shaped bacteria. Now, we go down to our second test. And remember, we'll look at characteristics. Find the outlier. The outlier this time happens to fall under sucrose fermentation. Now, shape test was kind of easy, self-explanatory. But sucrose fermentation, what's that? Well, sucrose fermentation is when sucrose is in a phenol red tube, and phenol red tubes act as a pH indicator to tell us when fermentation of selected sugar, sucrose in this case, is occurring. By fermentation I mean the bacteria is put into the tube via a loop that is sterile, remember, always sterile. Keep everything sterile. It's always good. So, you take your loop full of bacteria, agitate it into the sterile, into the tube, phenol red tube, and then you put it in an incubator, 37 degrees, for a day. When you come back, you will either see acid fermentation occurring, in which the bacteria is able to ferment sucrose and produce an acid and turn the pH from a neutral to high. No, to low. Sorry, I apologize. To low. But how are we able to see this visually? Well, the tube goes from a red to a yellow. But if the bacteria is unable to ferment sucrose, it stays at a red. So when we did this test, I found that the tube stayed red, not yellow. So check that one off the list. Goodbye, acid bacteria. Wow. Now we're down to two, our last two possible bacteria. On one, we got E. coli, and the other, Pseudomonas aeruginosa. We're going to duke it out in the third test, and now we'll hopefully be able to identify it. So again, we're going to look at any outliers, and we see that on one of the tests, Pseudomonas aeruginosa is positive, but E. coli is negative. And this happens to be the citrate test. The citrate test involves an auger slant tube that acts as a pH indicator, much like the phenol red, but this time it's blue. And if it's positive, when you inoculate the tube, the loop full of your bacteria and spread it on the auger slant tube, and you put it in the incubator at 37 degrees Celsius, and you wait a day, you should see kind of a green change in color from blue to green on the surface, and that's indicating that the test was positive. But if it's negative, the tube will remain blue. So flash forward a day, tube remained blue. So now we know what our unknown is, and it happens to be E. coli. Alright, so let's just kind of go over what I covered today. By looking at our characteristics of our four bacteria and looking for outliers, we're able to kind of construct a flow chart or a dichotomous key that helps us in assisting in choosing what tests we want to conduct to get to our unknown identity. But in this case, it was quite simple to choose. In other cases, it may not be so simple. But overall, a dichotomous key helps us in choosing what tests to be conducted, and it simplifies the process so much. Instead of going from thousands of tests maybe to conduct, you can limit it down to maybe less than 10. So, I hope that you kind of get an understanding of how a dichotomous key works and how we're able to identify bacteria from one another. Thank you.